Okay, so now you can hear me actually. Sorry, so I got distracted. Oh my god. Kicking the camera as usual. So I got distracted and did not connect my microphone before starting the streaming. Okay. We'll get back to where we left. Storage in the cloud is one of the sections of the Google Cloud Fundamentals core infrastructure. We've already seen the resource and access, all the resource hierarchy, various security layers, and then we've seen something about virtual machines and networks in the cloud. Okay, now we go with the storage cloud in the cloud.
Every application needs to store data, like media to be streamed or perhaps even sensor data from devices. And different applications and workloads require different storage database solutions. Google Cloud has storage options for structured, unstructured, transactional, and relational data. In this section of the course, we'll explore Google Cloud's 5 storage products: Cloud Storage, Cloud SQL, Spanner, Firestore, and Bigtable. Depending on your application, you might use one or several of these services to do the job.
Okay, so let's see what the...
Let's begin with Cloud Storage, which is a service that offers developers and IT organizations durable and highly available object storage. But what is object storage? Object storage is a computer data storage architecture that manages data as objects and not as a file and folder hierarchy, which is file storage, or as chunks of a disk, which is block storage. These objects are stored in a packaged format which contains the binary form of the actual data itself, as well as relevant associated metadata, such as date created, author, resource type and permissions, and a globally unique identifier. These unique keys are in the form of URLs, which means object storage interacts well with web technologies. Data commonly stored as objects include video, pictures, and audio recordings. Cloud Storage is Google's object storage product. It allows customers to store any amount of data and to retrieve it as often as needed. It's a fully managed, scalable service that has a wide variety of uses. A few examples include serving website content, storing data for archival and disaster recovery, and distributing large data objects to end users via direct download. Cloud Storage's primary use is whenever binary large object storage, also known as blob, is needed for online content such as videos and photos, for backup and archive data, and for storage of intermediate results in processing workflows. Cloud storage files are organized into buckets. A bucket needs a globally unique identifier and a specific geographic location for where it should be stored. And an ideal location for a bucket is where latency is minimized. For example, if most of your users are in Europe, you probably want to pick a European location, so either a specific Google Cloud region in Europe or else the EU multi-region. The storage objects offered by Cloud Storage are immutable, which means that you do not edit them, but instead a new version is created with every change made.
Objects are not edited, so whenever you copy them, sure.
Administrators have the option to either allow each new version to completely overwrite the older one, or to keep track of each change made in a particular object by enabling versioning within a bucket.
Okay.
If you choose to use versioning, Cloud Storage will keep a detailed history of modifications, that is, overwrites or deletes, of all the objects contained in that bucket. If you don't turn on object versioning, by default, new versions will always overwrite older versions. With object versioning enabled, you can list the archived versions of an object, restore an object to an older state, or permanently delete a version of an object as needed. In many cases, personally identifiable information may be contained in data objects, so controlling access to stored data is essential to ensuring security and privacy are maintained. Using IAM roles and, where needed, access control lists, organizations can conform to security best practices, which require each user to have access and permissions to only the resources they need to do their jobs, and no more than that. There are a couple of options to control user access to objects and buckets. For most purposes, IAM is sufficient. Roles are inherited from project to bucket to object. If you need finer control, you can create access control lists. Each access control
so I got distracted for a second.
is essential to ensuring security and privacy to an older state, or permanent in data object version of an object as needed. In many cases, personally identifiable information may be contained in data objects, so controlling access to stored data is essential to ensuring security and privacy are maintained. Using IAM roles and, where needed, access control lists, organizations can conform to security best practices, which require each user to have access and permissions to only the resources they need to do their jobs, and no more than that. There are a couple of options to control user access to objects and buckets. For most purposes, IAM is sufficient. Roles are inherited from project to bucket to object. If you need finer control, you can create access control lists. Each access control list consists of 2 pieces of information. The first is a scope, which defines who can access and perform an action. This can be a specific user or group of users. The second is a permission, which defines what actions can be performed, like read or write. Because storing and retrieving large amounts of object data can quickly become expensive, cloud storage also offers lifecycle management policies. For example, you could tell cloud storage to delete objects older than 365 days, or to delete objects created before January 1st, 2013, or to keep only the 3 most recent versions of each object in a bucket that has versioning enabled. Having this control ensures that you're not paying for more than what you actually need.
So now we'll finish with another video about Google Cloud Storage. Then we'll visit the page GCP GCS.
There are 4 primary storage classes in cloud storage. The first is standard storage. Standard storage is considered best for frequently accessed or hot data. It's also great for data that's stored for only brief periods of time. The second storage class is nearline storage. This is best for storing infrequently accessed data, like reading or modifying data on average once a month or less. Examples might include data backups, long-tail multimedia content, or data archiving. The third storage class is cold line storage. This is also a low-cost option for storing infrequently accessed data. However, as compared to nearline storage, cold line storage is meant for reading or modifying data at most once every 90 days. And the fourth storage class is archive storage. This is the lowest cost option, used ideally for data archiving, online backup, and disaster recovery. It's the best choice for data that you plan to access less than once a year, because it has higher costs for data access and operations and a 365-day minimum storage duration. Although each of these 4 classes has differences, it's worth noting that there are several characteristics that apply across all of these storage classes. These include unlimited storage with no minimum object size requirement, worldwide accessibility and locations, low latency and high durability, a uniform experience which extends to security, tools, and APIs, and geo-redundancy if data is stored in a multi-region or dual region.
Okay, so all of them: unlimited storage, worldwide accessibility and locations, low latency and high durability, uniform experience.
This means placing physical servers in geographically diverse data centers to protect against catastrophic events and natural disasters, and low balancing traffic for optimal performance. Cloud storage also provides a feature called AutoClass, which automatically transitions objects to appropriate storage classes based on each object's access pattern. The feature moves data that is not accessed to colder storage classes to reduce storage costs and moves data that is accessed to standard storage to optimize future accesses. AutoClass simplifies and automates cost saving for your cloud storage data. Cloud storage has no minimum fee because you pay only for what you use, and prior provisioning of capacity isn't necessary. And from a security perspective,
no prior provision of capacity. Okay, encrypts data on the server side. Use HTTPS. TLS.
Cloud storage always encrypts data on the server side before it's written to disk at no additional charge. Data traveling between a customer's device and Google is encrypted by default using HTTPS/TLS, which is transport layer security. Regardless of which storage class you choose, there are several ways to bring data into cloud storage. Many customers simply carry out their own online transfer using gcloud storage, which is the cloud storage command from the Cloud SDK. Data can also be moved in by using a drag and drop option in the Cloud Console, if accessed through the Google Chrome web browser. But what if you have to upload terabytes or even petabytes of data? Storage Transfer Service enables you to import large amounts of online data into cloud storage quickly and cost-effectively. The Storage Transfer Service lets you schedule and manage batch transfers to cloud storage from another cloud provider, from a different cloud storage region, or from an HTTPS endpoint. And then there is the Transfer Appliance, which is a rackable, high-capacity storage server that you lease from Google Cloud. You connect it to your network, load it with data, and then ship it to an upload facility where the data is uploaded to cloud storage. You can transfer up to a petabyte of data on a single appliance. Cloud storage's tight integration with other Google Cloud products and services means that there are many additional ways to move data into the service. For example, you can import and export tables to and from both BigQuery and Cloud SQL. You can also store App Engine logs, Firestore backups, and objects used by App Engine applications, like images. Cloud storage can also store instant startup scripts, Compute Engine images, and objects used by Compute Engine applications.
Okay, next activity, but we'll put pause and
Google
explore a little this documentation. So let's go to documentation. Cloud storage documentation. Cloud storage allows worldwide storage and retrieval of any amount of data at any time. You can use Google Cloud Storage for a range of scenarios, including serving website content, storing data for archival and disaster recovery, or distributing large data objects to users via direct download. Let's see the bucket location thing. This page explains the concept of bucket location and different locations where you can create buckets. A bucket's location defines the physical place where object data in the bucket resides. You permanently set a geographic location for storing your object data when you create a bucket. You cannot change the bucket's location after it's created, but you can move your data to a bucket in a different location. You can select from the following location types. A region is a specific geographic place. A dual region is a specific pair of regions. A multi-region is a large geographic area such as United States. The location type determines how your data is replicated and priced. Cloud storage stores object data in the selected location in accordance with the service-specific terms. The location information for a bucket is part of bucket's metadata, which you can view if you have permission to do so. When you choose the location for a cloud storage bucket, consider differences in availability and price as shown in the following table. If you choose region, one region, a specific region, you will have data redundancy across availability zones. RTO, recovery time, 0. Automated failover and failback on zone failure, no need to change storage paths. Lowest storage price, no replication charge, no outbound data transfer charge when reading data inside the same region. Okay, so I'm trying to see. To maximize performance and lower your total cost of ownership, collocate your data and compute in the same regions. Dual regions are both suitable for this purpose. Well, okay, data availability and durability. This page discusses concepts related to data availability and durability in cloud storage, including how cloud storage redundantly stores data, the default replication behavior for dual regions and multi-regions, the thorough replication feature for dual regions, and the cross-bucket replication feature. So key concepts are cloud storage is designed for 11.9's reliability, annual durability. Okay, so 11.9's annual durability. So the probability is that during a year, the probability that you lose your data before 1 year are really low, like below 6 zeros. To achieve this, cloud storage uses, 9 zeros, sorry. Yeah, because 11 are with the integer part and the decimal are 9 nines. Therefore, to achieve this, cloud storage uses erasure coding and stores data pieces redundantly across multiple devices located in multiple availability zones. Cloud storage redundantly stores objects that are written to it in at least 2 different availability zones before considering the right to be successful. Checksums are stored and regularly revalidated to proactively verify the integrity of all data at rest, as well as to detect corruption of data in transit. If required, corrections are automatically made using redundant data. The monthly availability of data stored in cloud storage depends on the storage class of the data and the location type of the bucket. For more information, blah, blah, blah. Objects stored in dual region or multi-region buckets are stored redundantly in at least 2 separate geographic places. For dual regions, you select the specific regions in which your objects are stored. For multi-regions, the specific data centers used for storing your data are determined by cloud storage as needed, but are located within the geographic boundary of the multi-region and are separated by at least 100 miles. This provides redundancy across regions at lower storage costs than dual regions. In the unlikely event of a region-wide outage, such as one caused by a natural disaster, dual region and multi-region buckets remain available, with no need to change storage paths. Objects stored in a dual region and multi-region buckets are typically replicated across geographic places using default replication. If one of the places an object is stored becomes unavailable after the object is successfully uploaded but prior to it being replicated to the second location, cloud storage's strong consistency ensures that stale version of the object won't be served and that subsequent overwrites aren't reverted when the region becomes available again. There's a lot here. Objects stored in a dual region can optionally use turbo replication to achieve a faster, more predictable replication across regions. To achieve redundancy between a region pairing not available as a dual region, consider creating a separate bucket in each region and using storage transfer service, event-driven transfer, or cross-bucket replication to keep the buckets in sync. Redundancy across regions. While traditional storage models often rely on an active-passive approach with primary and secondary geographic locations, cloud storage provides an active-active architecture based on a single bucket with redundancy across regions. This simplifies the disaster recovery process by eliminating the need for users to replicate data from one bucket to another or manually fail over to a secondary bucket in the case of primary region downtime. Cloud storage always understands the current state of a bucket and transparently serves objects from an available region as required. As a result, dual region and multi-region buckets are designed to have a recovery time objective 0, and temporary regional failures are normally invisible to users. In the case of a regional outage, dual region and multi-region buckets automatically continue serving data that has been replicated across regions. However, redundancy across regions occurs asynchronously, and any data does not finish replicating across region prior to the region becoming unavailable is inaccessible until the down region comes back online. Data could potentially be lost in the very unlikely case of physical destruction of the region. Default replication in cloud storage is designed to provide redundancy across regions for 99% of newly written objects within a target of 1 hour and 100% of newly written objects within a target of 12 hours. Newly written objects include uploads, rewrites, copies, and compositions. Okay. So I have an idea about these concepts. Let's go with
Cloud's second core storage option is Cloud SQL. Cloud SQL offers fully managed relational databases, including MySQL, PostgreSQL, and SQL Server as a service. It's designed to hand off mundane but necessary and often time-consuming tasks to Google, like applying patches and updates, managing backups, and configuring replications, so your focus can be on building great applications. Cloud SQL doesn't require any software installation or maintenance. It can scale up to 128 processor cores, 864 gigabytes of RAM, and 64 terabytes of storage. It supports automatic replication scenarios, such as from a Cloud SQL primary instance, an external primary instance, and external MySQL instances. Cloud SQL supports managed backups, so backed up data is securely stored and accessible if a restore is required. The cost of an instance covers 7 backups. Cloud SQL encrypts customer data when on Google's internal networks and when stored in database tables, temporary files, and backups. And it includes a network firewall, which controls network access.
Supports managed backups. Encrypts customer data when on Google's internal networks. Storing database table, temporary files, and backups.
Access to each database instance. A benefit of Cloud SQL instances is that they're accessible by other Google Cloud services, and even external services. Cloud SQL can be used with App Engine using standard drivers like ConnectorJ for Java or MySQLDB for Python. Compute Engine instances can be authorized to access Cloud SQL instances and configure the Cloud SQL instance to be in the same zone as your virtual machine. Cloud SQL also supports other applications and tools that you might use, like SQL Workbench, Toad, and other external applications using standard MySQL drivers.
Okay.
The third core storage option offered by Google Cloud is Spanner. Spanner is a fully managed relational database service that scales horizontally, is strongly consistent, and speaks SQL. Battle tested by Google's own mission-critical applications and services, Spanner is a service that powers Google's $80 billion business. Spanner is especially Google Cloud's second core storage option is Cloud SQL. Cloud SQL offers fully managed relational databases, including MySQL, PostgreSQL, and SQL Server as a service. It's designed to hand off mundane but necessary and often. The third core storage option offered by Google Cloud is Spanner. Spanner is a fully managed relational database service that scales horizontally, is strongly consistent, and speaks SQL. Battle tested by Google's own mission-critical applications and services, Spanner is a service that powers Google's $80 billion business. Spanner is especially suited for applications that require a SQL relational database management system with joins and secondary indexes, built-in high availability, strong global consistency, and high numbers of input and output operations per second. We're talking tens of thousands of reads and writes per second or more.
Okay, so it's a managed SQL server with steroids.
Google Cloud's fourth core storage option is Firestore. Firestore is a flexible, horizontally scalable, NoSQL cloud database for mobile, web, and server development. With Firestore, data is stored in documents and then organized into collections. Documents can contain complex nested objects in addition to subcollections. Firestore's NoSQL queries can then be used to retrieve individual specific documents or to retrieve all the documents in a collection that match your query parameters. Queries can include multiple chain filters and combine filtering and sorting options. They're also indexed by default, so query performance is proportional to the size of the result set, not the dataset. Firestore uses data synchronization to update data on any connected device. However, it's also designed to make simple, one-time fetch queries efficiently. It caches data that an app is actively using, so the app can write, read, listen to, and query data even if the device is offline. When the device comes back online, Firestore sync.
Synchronization to update data on any connected device. So we're already talking about a scenario where there are some clients. What the fuck? I don't have the context here. For mobile web and server development. Okay, data is stored in documents and organized into collections. Document can contain complex nested objects in addition to sub-collections. Okay, so we're talking about JSON in this case, maybe. Each document contains a set of key value pairs. Yeah, so JSON looks like things like JSON. For example, a document represents a user has the keys for the first name and last name with associated values. Query can be used to retrieve individual specific documents or retrieve all documents in a collection that match your query parameters. Multiple chain filters and combine filter and sorting option. Also performance proportional to the size of the result set. synchronization to update data on any connected device. Firestore uses data synchronization. However, it's also designed to make simple one-time fetch queries efficient. It caches data an app is actively using, so the app can write, release, and that even prices offline. Okay.
Synchronizes any local changes back to Firestore. Firestore leverages Google Cloud's powerful infrastructure, automatic multi-region data replication, strong consistency guarantees, atomic batch operations, and real transaction support.
Okay.
The last of Google Cloud's core storage options we're going to explore is Bigtable. Bigtable is Google's NoSQL big data database service. It's the same database that powers many core Google services, including search, analytics, Maps, and Gmail. Bigtable is designed to handle massive workloads at consistent low latency and high throughput, so it's a great choice for both operational and analytical applications, including Internet of Things, user analytics, and financial data analysis. When deciding which storage option is best, customers often choose Bigtable if they're working with more than 1 terabyte of semi-structured or structured data, data is fast with high throughput or it's rapidly changing, they're working with NoSQL data. This usually means transactions where strong relational semantics are not required, data is a time series or has natural semantic ordering, they're working with big data running asynchronous batch or synchronous real-time processing on the data, or they're running machine learning algorithms on the data. Bigtable can interact with other Google Cloud services and third-party clients. Using APIs, data can be read from and written to Bigtable through a data service layer like managed VMs, the HBase REST server, or a Java server using the HBase client. Typically, this is used to serve data to applications, dashboards, and data services. Data can also be streamed in through a variety of popular stream processing frameworks like Dataflow Streaming, Spark Streaming, and Storm. And if streaming is not an option, data can also be read from and written to Bigtable through batch processes like Hadoop MapReduce, Dataflow, or Spark. Often, summarized or newly calculated data is written back to Bigtable or to a downstream database.
Okay, I'm going for it even if I'm not 100%.
Now that we've covered Google Cloud's core storage options, let's do a comparison to help highlight the most suitable service for a specific application or workflow. Consider using cloud storage if you need to store immutable blobs larger than 10 megabytes, such as large images or movies. This storage service provides petabytes of capacity with a maximum unit size of 5 terabytes per object. Consider using Cloud SQL or Expander if you need full SQL support for an online transaction processing system. Cloud SQL provides up to 64 terabytes, depending on machine type, and Expander provides petabytes. Cloud SQL is best for web frameworks and existing applications, like storing user credentials and customer orders. If Cloud SQL doesn't fit your requirements because you need horizontal scalability, not just through read replicas, consider using Spanner. Consider Firestore if you need massive scaling and predictability together with real-time query results and offline query support. This storage service provides terabytes of capacity with a maximum unit size of 1 megabyte per entity. Firestore is best for storing, syncing, and querying data for mobile and web apps. Finally, consider using Bigtable if you need to store a large number of structured objects. Bigtable doesn't support SQL queries, nor does it support multi-row transactions. This storage service provides petabytes of capacity with a maximum unit size of 10 megabytes per cell and 100 megabytes per row. Bigtable is best for analytical data with heavy read and write events, like ad tech, financial, or IoT data. Depending on your application, it's possible that you might use one or several of these services to do the job. You may have noticed that BigQuery hasn't been mentioned in this section of the course. This is because it sits on the edge between data storage and data processing, and is covered in more depth in other courses. The usual reason to store data in BigQuery is so you can use its big data analysis and interactive querying capabilities.
Okay, so we have a 1 hour lab here. I hope, as always, to be able to do it in half the time. We'll try it. Let's see one thing here, why it's always disappearing this part of the bar. So then we have just the quits. Okay, let's go. So, oh, Jesus Christ, I'm always kicking the fucking camera. Okay. Okay, so Google Cloud Fundamentals. Get started with cloud storage and Cloud SQL. In this lab, you create a cloud storage bucket and place an image in it. You also configure an application running in Compute Engine to use a database managed by Cloud SQL. For this lab, you configure a web server with PHP, a web development environment that is basis for popular blogging software. Outside this lab, you will use analogous techniques to fill these packages. Okay. And you learn how to perform the following task. Create a cloud storage bucket and place an image into it. Create an SQL instance and configure it. Connect to the Cloud SQL instance from a web server. Use the image in the cloud storage bucket on a web page. So let's go start the lab. And let's open this one in incognito. First of all, let me do the procedure to login in my student Google Cloud account. Okay, I have it. Now, let's see. Okay. Perfect. What's this? Oh, this will be for the SSH. Okay. Let's go. Then for task one, sign into the Google Cloud Console. Okay, so let's see here. Deploy a web server VM instance. Create a compute engine instance, blog host. Okay, so let's go compute engine VM instances. Create an instance. The name will be blog host. For region and zone, select the region and zone assigned by Quick Labs, which is US East 4. Okay. US East 4A. Machine type. I will accept the default. For boot disk, if the image shown is not Debian new Linux 12, click change and select Debian new Linux 11 bullseye. Okay, let's see. Boot disk. So I already have, if the image shown is not, okay, it is the 12, so I will not change it. Leave the defaults for identity and API access. For firewall, click allow HTTP traffic. Click advanced option to open a section of the dialog. Click management to open that section of the dialog. Scroll down to the automation section and enter the following script as the value of the startup script. So advanced option, management, and it was in the startup script. So it will do an update. It will install Apache, PHP, and PHP MySQL, and then we'll restart Apache to actually make it work immediately. Sorry, if you accident to put in it won't be okay. Okay. Leave the remaining setting as the click create. Okay, get about news launch and be fully available for use. On the VM instance page, copy the bloghost VM instance internal and external IP to a text editor for use. Okay. Oh shit, I need to wait for this. Okay, it did it. Check my progress. Okay, therefore, task 3, create a cloud storage bucket using the gcloud storage command line. All cloud storage bucket names must be globally unique. To ensure that your bucket name is unique, this instruction will guide you to give your bucket the same name as your Google Cloud Project ID, which is also globally unique. Cloud storage buckets can be associated with either a region or a multi-region location, US, EU, Asia. In this activity, you associate your bucket with the multi-region closest to the region zone that Quick Labs or your instructor assigned to you. On the Google Cloud Console on top, activate Cloud Shell, click Continue. For convenience, enter your chosen location into an environment variable called location. Enter one of these commands. Okay, first of all, I need to copy these and these. Okay, then it was saying to for convenience version. So we need to put US. Okay, export location US. So activate the Cloud Shell. Continue. Now we have our Cloud Shell running in our temporary project. We immediately go with export location US. In Cloud Shell, the dev shell project ID environment variable contains your project ID. Enter this command to make a bucket name after your project ID. So location, we already defined it. Cloud storage buckets create location and GS. Okay, so it will be called like this. Authorize. Creating. Okay, perfect. If prompt, click Authorize. Retrieve a binary image for a publicly accessible cloud storage location. So cloud storage, copy into cloud training. Okay, we will create a new bucket called like this, a subfolder, or my excellent blog, blah, blah, blah. So my excellent blog, what? Oh no, this is a cloud bucket existing code like this. So doing this will basically create a copy cloud storage buckets. So this is the bucket we just created, and in the folder, in this folder here. Oh no, this is just retrieve. Copy the binary image to your newly created. Okay, so we have temporary memory. Now we will have it in our bucket here. Cancel. How do we? Oh, refresh. Okay, now we have it. Okay, so we cannot visualize it. I mean, we will need to download it. My Excel blog. Okay. Copy the binary image and modify the access control list of the object you just created so that it's readable by everyone. So gsutil is a command for Google's cloud storage. Access control list, change user in all user. Okay. And the target for this change in the access control list. Okay, check my progress. Great. Task 4. In the Google Cloud Console, so we'll create the Cloud SQL instance. Click SQL, create instance, choose a database engine, choose MySQL. Choose a Cloud SQL edition, click Enterprise, and then select Sandbox. So let's go. Yeah, create instance. Dismiss. I'm not interested in this at the moment. Create an instance. Okay. Choose a database engine. Choose MySQL. Choose a Cloud SQL Edition Enterprise. We'll go with Enterprise. The differences are the availability, as you may see, the decimal are 95 instead of 99. Less than 60 seconds planned maintenance downtime. This is sub-second. Then we have a general purpose machine, general purpose machines. And then we have up to 7 days point in time recovery windows, up to 35 days. And then we have other things that Enterprise doesn't even have. So from for instance, ID type blogdb. And for root password, type a password of your choice. Shit. My password will be this one. I will make a copy. Okay. Now choose a password that you remember. There's no need to obscure password because you're mechanism to connect that are on top of it. Select single zone and set the region and zone assigned by Quick Labs. Region, single zone. US East 4. This is the same region and zone in which you launch the blog host instance. The best performance achieved by placing the client and database. Okay. Choose the instance. Okay, create. So wait for the instance to finish deploying. It will make a few minutes. It will take a few minutes. Click the name of the instance to open its detail page. So currently we're still above the hour. Nice. Okay, so to resume, we have a virtual machine. Then we will have this DB. We already have a bucket also. We will store the objects in the bucket and some transitional data in the DB. Okay. Let's see. It needs another minute and a half. Let's go to billing. Let's see what happens in billing for this type of projects. Zero, zero, zero. And what do we have here? Nothing really. Oh, it's taking a while. Okay, so we already have some data here. Let's see one thing. So click the name of the instance to open its detailed page. From the SQL instance detail page, copy the public IP address for your SQL instance to a text editor for use later in this lab. Still to connect to, oh, look here. So, okay, we have this. Click users menu on the left hand side and click add user account. Yeah, I still need to wait. Okay. Well, I will just take a pause and go to take some water. So it looks like we finally have our SQL instance. Great. So now we can go to users. Let me see if the IP address is the same. Yeah. If we go to user and click add users, we actually can do for username type blog user. We put everywhere the same password. Click add. Okay, now wait for the user to be created. Click connections menu on the left hand side and then click networking tab. Click add a network. If you're offered to choose between a private IP connection and public IP connection, choose public if for purposes of this lab. Web front end. For the network, type the external IP address of your blog host VM instance, followed by 32. Okay. Okay. Be sure to use the external IP address of your VM instance followed by 32. Do not use internal IP address. Do not use the sample IP address shown here. Okay, now if the message appears like another operation is in progress, wait for a few minutes until you see the green logo and save configuration. Okay. Another operation is in progress. Okay, now it's been done. Let's see, great. So now we have task 5, configure an application in a compute engine instance to use Cloud SQL. So we SSH into our VM instance. VM instances. We SSH into it. Okay. Now I need to show you what I'm doing there. Okay. So now it says in your SSH session in Bloghost, change your working directory to the document root of the web server. www.html. Use the nano text editor to edit a file called index.php, sudo nano index.php. Okay, paste the content below into the file. So this is an HTML page. Control O to write out, right? Yeah. Okay, Control X to exit. Restart the web server. So, okay. Open a new web browser tab and paste into the address bar your blog host VM instance's external IP address followed by index.php. This will be okay. So first of all, let me reduce this. And what you see is this, yeah. So here we go. We have it. Let's see. Continue to the side. We don't have a certificate. Welcome to my excellent blog. Database connection failed. Cloud SQL IP name of the service not known. Oof. Oh, when you load the page, you will see that the content includes an error. Great. This message occurs because you have not yet configured PHP's connection to your Cloud SQL instance. Return to your SSH session blog post. Use the nano text editor to edit the index PHP again. So let's get back this one. Okay. And it says in the nano text editor, replace Cloud SQL IP with the Cloud SQL instance public IP address that you noted above. Leave the quotation marks around the value in place. So this is the public IP of the Cloud instance. Oh, I see. Okay. Replace also the DB password. Okay. Restart the web browser. Return to the web browser tab in which you open your blog post VM instance external IP address. When you load the page, the following message appears. Okay. So we need to try again. This will need to be reduced. And the VM, what's this? Index PHP connected successfully. In an actual blog, the database connection status will not be visible to the blog visitors. Instead, the database connection will be managed solely by the administrator. Let's go. Now configure an application in a Compute Engine instance to use a cloud storage object. So what we've done here is configure an application Cloud Compute Engine instance to use Cloud SQL. And it has been done just by placing this and using this connection piece of code. So try, yeah. Okay, therefore, now let's go to task 6, configure an application in a Compute Engine instance to use a cloud storage bucket. In cloud storage buckets, click the bucket that is named after your project. In this bucket, there is an object called My Excellent Blog PNG. Okay, so let's go to this and go to buckets. And inside the bucket, we have this PNG. Copy URL behind the link icon that appears in the object's public access column or behind the words public link if shown. This one. Okay. If you see neither link, try refreshing. If you still do not return closed shell, access control shell command was successful. Return to your SSH session in localhost VM instance. Enter this command to set the working directory to the document root of the web server. Okay, so I think we're already there. Yeah. Use, then we need to modify again this, and then use the arrow keys to move the cursor to each one element. Press enter to open up a new blank screen line, and then press URL. Okay. Paste this HTML markup immediately before the URL. Okay. So we need, let me see if we actually have a link here. Yeah. Okay, so we have H1 to same place. Because of the line that contains H1 element. Okay. I'm curious if I do like this. Yeah. And I will put Jesus Christ. My keyboard is fucked up. I'm using a different keyboard. It's back to my layout, so I will need to do this first. And then from here, I will copy the URL. Then I will close with this. Okay, the result line will look like this. The effect of the step is to place the line contained immediately before the line containing H1. Do not copy the URL shown here. Instead, copy the URL shown by storage browser. Okay. Now we need to save basically. Yeah. Then we restart. Yeah, we already have it, but over. Return to the web browser and check. Okay. Now we need to reduce this and getting back here. Going again to our VM public IP and writing index PHP. We can see the image. Let's go. In this lab, you configure the Cloud SQL instance and connected an application in a Compute Engine instance to it. You also work with the Cloud Storage bucket and your lab. So to recap, to use the image in the bucket, we just put the URL to the image, the public URL in the SRC. So it's basically publicly available for all the users connecting to this VM public IP, which hosts an Apache server, which receives requests in HTTP. So let's exit from here. End lab. Can close this and this. It was good. Okay, now we completed this. Let's go. We can have the quiz. Which relational database service can scale to higher database sizes? I mean, Spanner, because Cloud SQL, once you configure it, will be a static configuration. Instead, Spanner is a dynamic configuration, auto-scaling configuration. What is the correct use case for cloud storage? Data warehousing. Depends. What do we exactly mean with data warehouse? Cloud storage is well suited to providing the root file system of a Linux. No, cloud storage is to the durable, highly available object storage. Why will the customer consider the call line storage class? 100%. Next.
In this section of the course,
In the next section, we'll have the containers in the cloud. Great. So for now, I will stop here. But before, I would like to see here what happens. 4 days remaining. Man, they're proceeding. And the next day, I will not do videos, I think. So for this time, I will not succeed in going to the Gold League. But yeah, I will have better moments. For now, I will just close here for today. And thank you for being with me, even if I have zero viewers. Therefore, I just say thank you to me, as I have been here all the time. And I hope this video can be useful for someone in the future. I will just continue recording them, going through all the fundamentals, in this case for the infrastructure, but in the future also other modules of the GCP. So let's go, let's continue. Let's